For me, I'm not recording today. Okay. Okay. So and also I need to mention one more thing for the Lab 7. I think Lab 7. Every time we load my website, something like this one, they lost some format, then please reload again. Okay, I think I need to update the server. Okay, so the Lab 7 here, the PWM definition. This one, I sent all the email to all of you guys last night, okay, about this PWM, my definition for PWM. So for the PWM DIV mask, the previous I give you the 3. No, 3 is incorrect. So it should be the 7 because we use the 3-bit. Okay, we use the 3-bit for the PWM device. Okay, so 3-bit 111 should be the 7, not the 3. The previous I put the 3 is just 2-bit. Okay, so that's why when you configure, you get the incorrect the result, especially for the servo. Okay, if the servo you cannot get exactly the frequency and the pulse width, then you will not trigger you are not driving your servo. Okay, so this one should be the 7 PWM mask, and here PWM 1294 PWM DIV mask. Yeah, 7 is not 3. Okay, please update. Okay, so please update this one in your my device.h file. Okay, now it's for the PWM. And for timer, if you have time, then you just type it. Okay, after class. After class, I double checked everything. Yeah, the mask is 3 bits, no problem. Okay, so after class, you can type this one. And today I'm going to tell you how to configure the timer. Okay, so create a new project. The project name is the Lab 10, the ultrasonic. Okay, and change the warning AC file like warning. Okay, change this one and add your common and the EasyTiva libraries, both the folder to your include path, and change the debug to the standardized ICDI and the utility to the standardized ICDI. Right. And one more thing is the current the cow version, they still have some bug. Okay, so I find when I try to debug the code, use the newer version, the version 6, I find sometimes when they convert the C code to the assembly, they're a little bit different with the previous version. Okay, the version 6, the default the compiler, you can see here, default. The compiler use the version 6. The version 6 try to do a lot of optimization for your from your C code to the assembly code or to the machine code. Okay, and so sometimes when you debug a code, they may optimize some statements. It's very hard to debug. So if that happens, you change this one, change your compiler back to default version 5. Okay, so let me show you how to debug the code later. Okay, so if anything wrong, you think your code is no problem, but when you compile the code and load it to your board, but to get your unspec'd behavior, and change the one to version 5. Change it to version 5, then click the project, clean target. Okay, so tell the compiler while we clear delete all the previous compiler file. Okay, then rebuild. Okay, then click rebuild. Okay, so you can rebuild the program again. Then write. Okay. Okay, so let me finish this code, and later on I'm going to show you how to debug the code. Okay, this is the first thing, and anything we see here. Yeah, the compiler. Okay, so if something wrong for the version compiler for version 6, then change it back to the version 5. And the second one is they just announced the new version. I think 2 days ago. Okay, the current version is 5.33. I think your version is 5.32. just released 2 days ago. Okay, so after class, okay, please, if you have high-speed internet, you can download it now. Otherwise, after class, please download the new version and install it. Okay, they fix some bug. Okay, so yeah, check update here. Okay, so re-download the new version and install on your computer. Okay, so now give me the feedback if you already created the new project for the Lab 10 ultrasonic and put a yes mark under your name. Okay, create a new project and then copy the code. Copy the code. So here, if you use a small board, here this is connection, and this is the example, the sample, the firmware code. Okay, it's a copy, and then pass it to your main.c source file. Okay. Okay, so copy, pass that one to your main.c source file. Okay, so you finish it and put the yes mark. Yeah, you put the no mark. Thank you. Some student you put no mark and I will wait for you. Okay. Okay, you finish, you put the yes mark. You stand near time and put the no mark. And once you finish, don't forget to change the no mark back to the yes. Okay. Okay, then this is the connection. We connect the V bus. The V bus on the small board is this is 5 volt. Okay, the V bus is the voltage from USB. That one we call the V bus, and the standard USB the voltage is 5 volt. Okay, so 5 volt connect to the VCC. You can check the sensor, your ultrasonic sensor. They can push the 4 pins, 2 pins for the power, VCC and the ground. Okay, so the power in this ground. And the 2 control pin. One is trigger. The trigger pin we connect to the PB2. Okay, so PB2 is output pin. Another one is the input pin. So this input pin connect with one 220 or 200 ohm the resistor, and they connect to the PF2. Okay, so we're gonna use the PB2 and the PF2. But for PF2, we need to connect this one to the timer. Okay, so PF2 for timer. And go back to here. So we can set up the timer for the PF2. Then we check the port control register for the PF2. So here, PF2. This is the port control register for the small board. You can see here T1CCP0. The T1 is the timer module 1. CCP0. Okay, so each the timer they have the two. They can generate the two the timer output or input. Okay, whatever each the timer the module they have the two the timer or timer A and the timer B. Timer A is the CCP0 and the timer B is the CCP1. Okay, so for the T1 CCP0, okay, so this one's been the timer module 1, and each module they have two timers, timer A and the timer B. Then here we're going to use timer A. Okay, so copy, and the port control register number is 7. Okay, so let's go back to code here. So port control register is 7, and the T1 CPP0. Double check it. T1 CPP0. Yeah. And for the big board, we're going to connect the echo pin to the PL4. Okay, so for the big board PL4, let's see, PL4 is here. So for the big board, the PL4 T0CCP0. Okay, so CCP0 is timer A, and T0 is timer the module 0. Okay, so this is for the big board T0CCP0. Okay, so here let me use the small board. Okay, the small board T1CCP0. Okay, so the first one we need to enable the clock to the module 1. Okay, so type here T1 CCP 0, which is timer module 1, and we're going to use the timer A. So CCP 0 is timer A, and CCP 1 is timer B. Okay. Okay, so we're going to enable the timer, the module 1. For the big board, you have to enable the timer module the 0. So I'm going to put a comment here. For big board, you're going to use the, let's see which pin. For big board, you use the PL4. Okay, so PL4. So for the big board is PL4. And the port control register for the big board PL4 is a 03. Okay, and the T0 CCP0. Yeah, so this is for the big board, and for small board, for the small board, enable the timer module 1, and for the big board is module 0. Okay. Then next one, we need to disable timer A or B. Okay, so now here we use the timer A. Okay, so we just disable the timer A. So which the one we're gonna use? Open my device. Oh, I have to define my device for this one. Yeah. Okay, here I will define a timer. Enable this pin. Okay, so we're gonna disable the timer. Okay, so we're gonna set that is the enable pin to the 0, and the write is the value to the back to the timer control. The control the register. You can see here this timer 1. If you use the module 1 and put the 1 here. Okay, so if we use the module 2, then put the 2. For the big board, you should use the timer 0, because that is the if you put the 0, which means we're gonna control the timer, the module 0. Okay. So for the small board, this number, this 1 is the timer module 1. So here we're going to disable the timer A, okay, because here we're going to use timer A. Right? Then the CF config. The second step is config. Okay, so which one we use? For the for this one, we're going to use the 6-bit timer. Okay, so 6-bit timer is this one. Timer config. Okay, we're going to configure the timer as a 16-bit the timer. Okay, so the timer config the timer to the 16-bit. Okay, then we need to configure the timer TAMR, the timer, the mode. Okay, so let me check the datasheet. Timer TAMR. Okay, so timer A, the mode. Okay, so usually here we just need to know first one is the clock, the direction. Okay, so here this one. Okay, we're going to use the countdown the mode, and we also want to use the age time mode. Age time mode is the capture mode. Okay, so we're going to use the age time mode for the timer A, and the counter, the direction is countdown mode. Okay, so here I didn't really define here. Okay, so it's the countdown timer, the countdown, and we're gonna use the capture mode. Timer capture mode. Okay, so double check. Yeah, capture mode. And one more thing is the capture is the age time. Okay, so let me go over here to check this is the register for the TAMR, the timer A, the mode. Okay, so this timer A, so we need to focus on the 3-bit. I forgot to highlight this one. Also include this one. Okay, So is the direction. Okay, we need to set this one to the countdown mode, and here, or not to this one, not to this one. And second one is the timer A, the capture mode. Okay, so for the timer, they have two capture the mode. One is the count mode. So the count mode, they count your the rising edge, how many rising edge you have. Okay, so if your input clock on the rising edge or falling edge, depending on your configuration, they can increase counter by 1. Okay, so that one just like your the counter. You can see that when you go to the Costco, there's one guy here to check your the Costco car, and also there on their hand they have one the counter. Okay, so they can push button and they count out how many the people to go to the Costco today. Okay, so they come to that push button. So that one config which age they can trigger this timer. And every time they can trigger timer, they will add the count by 1. So that one is the age count. Oh, no, we don't want to count your age. We want to know what is the period, the person period. So we can use age time mode. So capture mode, we're going to use the age time mode. And here, we can configure the timer A, the mode, the one-shot mode, or the periodical timer mode, or the capture mode. And we're going to use the capture mode. So then in our code, first one is countdown mode, and we can configure timer A using the capture mode. Then the capture will choose time the capture mode. We use the age time mode. Okay, so this one here is the time mode. Then here, control. So you can see capture the rising age or falling age or post age. So use the post age. So enable B, this is A, enable B, this is A event. So yeah, okay. So for the timer A, the event, I use the post age, okay, rising and falling. Code. So we define here. Define the post age. Oh, I need to define one more. I also need to define this is a timer A, the event. I forget to define the event bit. Okay, I will update my website again. So event bit. Why? Because according to the datasheet. Okay. So according to the datasheet, this is the control the register. We can control the timer A and the timer B. Okay. So timer A, the event, the bit is the bit 3 and 2. And for the timer B is the bit 10 and 11. Okay, so they have sent the value, sent the definition, but we need to update this one to the different locations. Okay, so we need to define the timer A events bit 2 and the B is the bit 10. And also enable A is bit 0. Let's see, enable A. Oh, I think I already shipped. Give me a second, let me double check. Oh, I already shipped this one, so we don't need this bit because I already shipped it. See, yes, I already shipped it now, so I don't need it. Sorry, it's my fault. Okay. So we're gonna define this one. Okay, using the we're gonna define this one the both age. Okay. So to define the both age, because the the timer event, they use the 2 bits. Okay, so we need, before we reset that one to the value we need to clear. Okay, so we need to use the bitwise AND to clear that the timer A, the event, that 2 bit, and then reset the value to the value that we want. Okay, so first one we need to clear the event. Okay, using the event mask, we can clear that 2 bit, and then set the mode. Okay, to the both age mode. Okay, and step 6, we're gonna configure your load value. Okay, so for the timer A, we use the 2 register to store your load value. The first register, the register, the TAILR. Okay, so this is the timer, the initial load value. Okay, so this one is the 16-bit, and not the 8-bit is stored into the TAPR. This one is the prescale the bit. Okay, suppose we set it to FF and this one FFF. Okay, so why the different value? Because for the TAILR, it's a 16-bit. 16-bit. Yeah, and for the TAPR, it's the 8-bit. Okay, so 16 plus 8, so totally I have the 24-bit. Okay, then the IMR, this one is to control the interrupt. So we are not using any interrupt here, so we clear that bit to the 0. Okay, so we configure load value and also put this on 0, which means we are not using any interrupt. Okay, then we need to enable the timer. Okay, so we're going to enable timer A. Okay, so here, yeah, I finished the code. Okay, so for the small board, we're going to use the timer, the module, timer 1. So module 1, module 1, and then change this one to the 1. And CCPA, so CCPA, we use the timer A. Okay, so you can see here the configuration, I use the timer A. And the timer A, TAMR is timer A, the mode register. Okay, it's the countdown mode and the capture mode, and then the capture we're going to use the age time mode. Okay, then we need to set the how to trigger our timer. Okay, so the first one we need to clear the event bit, because event bit they are 2 bit, so we'll clear that 2 bit and set the age, okay, to the both age. So which means the rising age and the falling age both can trigger out the capture function. Okay, then we set the load value. And, in the timer, we're going to use the 2 registers to store our load value, because the load value is 24-bit, and the TAILR is the register. They only store the 16-bit. Another 8-bit is stored into the prescale this bit, TAPR this bit. Suppose we set it to the FF. Okay, so which means the timer never come down from the FF, 6F, come down to 0. Okay, once they come down to the 0, then they can reload this value to the timer counter, and they continue to come down to 0. Okay, and the IMR is interrupt the mask. We're gonna use any interrupt, so put a 0 here. Okay, so then the last step, we need to enable the timer. Okay, so here we're gonna use the timer A, so we're gonna enable timer A. Oh, sorry, here change this one to the timer A. Okay, then set up GPIO. Oh, let me copy this code. Let me do this one again for the big board. Okay, so for the big board, let's see. So I just copy the timer and set up GPIO for the big board. Okay, so for the big board, PL5. So Use PL5. Okay, so PL5 T0 CCP0. So for the people, we're going to enable the timer module 0. Okay, so double check that. Okay, then we're going to enable the clock for the timer module 0. Okay, then CCP1. Hold on, let me double check. PL5. So PL5 here. Oh, PL5 is T0C CCP1. Okay, so double check. Yeah, PL5. Yes. Oh, hold on. Then another one is trigger pin. Trigger pin PL5. So we're gonna use the we're gonna use the PL4. So I need to change my code. That one is PL4. Okay, so PL4 is the T0CCP0. So okay, so still the module 0. Okay, then CCP0. Okay, so CCP0 is the timer A. Okay, so we're gonna okay. So here is timer A. Enable. Okay, so we can disable this timer A. Okay, then the mode for the timer A, we can configure this one as the 16-bit. Okay, so for the timer 0, the CFG, okay, the config, we can configure that one using the 16-bit. Okay, and next one is the timer A, the mode. Okay, so timer A, the mode, we're gonna use the countdown mode. Okay, then the capture mode. And then using the age, the time for the capture. Okay. And next one, we need to configure timer event. Okay, we're gonna use the both age. Okay, so that one is the timer A, the event mask. The first one, we need to clear that 2-bit to 0. Then we're gonna reset that one to the both ages. Okay, and then for the TAIL and TAPR, both the registers set to the FF, and IMR is the interrupt mask. The register, we are not use any interrupt, so set the 0. Okay, then we enable the GPTM, general purpose timer. Okay, so using the here timer A enable. After that one, we're going to enable timer A. Okay, so this is the setup the timer for the big board. Okay, so let me clear this one. Okay, so this one is for the big board. Okay, then in my the Cal compiler is for the small board. Okay, so this one is for the big board. Oh, so yeah, this one for small, this one for big board. Okay, so any question for this one? For the setup the timer, if you finish, then put the yes mark under your name. If you have any questions, let me know. Put the no mark, or you can unmute your microphone. You send a message to me. Okay, so this is for the big board. This one for big. Oh, sorry. This one for small board, and then this one for the big board. Okay, the Notepad++ is for the big board, and in my Cal compiler is for the small board. Okay, so 8 student give me the feedback. So yeah, please let me know if you work on, if you finish the code for the setup timer. Okay, for the setup timer, and put the yes mark under your name. Yes, I got that email, the message from the student. Yes, only difference between the big board and the small board is the one uses timer module 1, another one uses timer module 0. Okay, so you can see here, this is the T1 CCP0, this one for the small board, and for the big board, you use a T0 CCP0. Okay, so small board use the module 1, and the big board use the module 0. Only difference here, the module. Okay, so of course here you can see here timer 11111. Okay, so for the small board, you can change this one to the 1. And for big board, this one should be the 0. Okay, the reason is